This one says assume that a procedure yields a binomial distribution with a trial repeated n times. Use the binomial probability formula to find the probability of x successes given the probability p of success on a single trial. Okay, let me grab that formula. Um, Let me find an easy version of it. It's difficult to understand, but it's relatively easy to apply. Let me look for a good version of the formula that's easy for me to share with you. Bear with me. Okay, it's gonna look much more difficult than it actually is, but I've got to grab it the way I found it here. Okay, let me grab it and let me paste it over here. Um, I'm trying to grab it here from my tool. There it is. Okay, here we go. All right, so the nice thing is that the calculator is going to do a lot of the work for us. And it's going to be really straightforward because we only need to compute the probability that x is 2. And this here, which is the same as this here, is the same as n choose r. So 5 choose 2. And then it's the probability of success is 0.70. And it's to the second power because we want 2 successes. Now, we want to think of so P is 0.70. So Q, the probability of failure is 0.30. And that value is this here. So this is actually 0.30. And another thing is that this value and this value will always add up to n. So what I'm saying is that this is 3. Since this is 2, this is 3. Because 2 plus 3 is 5. Okay, that said, let's put it in the calculator. Not that calculator. this calculator. And the calculator will do all the work. So then it is math, probability, NCR. That's 5 choose 2 times 0.7 to the second power times 0.3 to the third power. And our answer is 0.1323. An even easier way of doing it is to go to distribution. Let me see. And you're going to go to binomial PDF. And I've put in the data already, but the 5 is this 5. Then P is 0.7. The X value is 2. And when I paste it, I get the same answer that I got when I used the full blown out formula.